Good afternoon, everyone. My name is Olumayowa. I'm a DevOps engineer. Um, I started um, I started my career in IT about 10 years ago, where I started working as a network engineer, an access network engineer. From there, I did graduate into doing Metro Ethernet. From Metro Ethernet, I did a bit of core network engineering before I moved to the subsea side of network. I worked as a submarine network engineer for I think about 4 years, where I covered about five submarine cable landing stations between Europe and West Africa. And within that period, I was responsible for most of the traffic. I was responsible for most of the traffic coming into Africa for a few of the FANG and the MANG providers. After a while, I left the subsea industry to focus mainly on doing DevOps. I mean, because of my love and passion for automating boring things, I decided to move from doing network engineering to automating infrastructures, basically. So today, I'm going to speak mainly on DevOps in network engineering, infusing network engineering to DevOps. So this is more like this is what we could call network programmability or network automation. So I'm just going to run us through with with the slide I'm going to share today. So it starts with why DevOps in network engineering. Why DevOps in network engineering? What's the reasons why we do DevOps in network engineering? Basically, in network engineering, one of the reasons why, part of the reasons why we try to implement the DevOps culture is agility, which involves enabling faster deployment and scaling of network services. And talking about agility, we're looking at making deployments quite faster than the traditional method of deploying network infrastructures. I know a bunch of us that are familiar with configuring network infrastructures know that most of the time we have to connect to routers and switches locally to implement or to onboard new devices, which is actually the traditional method. But let's give a scenario where you're trying to integrate a large scale network that involves, let's say, about 500 routers and about 2,000 switches. Would you start going from one location to the other in trying to onboard these router and switches? No, because that's actually going to take more time. It's going to cost you more money because you're looking at employing so much workforce. Then there's actually room for human error, which is part of why we now start integrating programmability and automation into network infrastructures. Also, one of the reasons why we do this is automation. Automation actually reduces the need for manual configuration, manual intervention, which part of why I said in agility. And this also helps us to reduce human error. Also, efficiency, reliability, and innovation. So now, this time around, like those days where we used to have to think of how to implement solutions traditionally, nobody really has that time to start implementing solutions traditionally. I could remember my first time um, getting involved in network automation. I think that was about 2017, 2018. We were going to implement some certain services, and I had a certain conversation with one of the OEMs then, and they actually showed me what it feels like to configure with zero touch. Because I personally am actually an engineer that's actually been used to configuring solutions within the terminal. I mean, I like to sit there in the terminal all day, configuring routers, configuring switches, and configuring other network devices. But I was able to see how I could do configuration without even having to log into without having to log in via the terminal, with just a single touch or with just a single script and few lines of scripts. We could configure about 500 nodes within 5 minutes, which I feel is actually a very beautiful thing to do and to experience. So we're going to talk about the benefits of network engineering. So benefits of DevOps in network engineering. So in one of the benefits of DevOps using using DevOps tools or following DevOps culture in network engineering is that we have an enhanced network efficiency and agility. Also, improved operational efficiency. Also, we have rapid deployment and scalability and customization and innovation. So talking about enhanced network efficiency and agility, we're looking at automated configuration management, where we use tools like Ansible, Puppet, Chef. Then we're also looking at CI/CD, continuous integration and continuous deployment. So there are ways actually where we could infuse CI/CD into the network engineering lifecycle, whereas we use some certain tools like Jenkins and GitLab CI, where we could have continuous integration going on within the pipeline. And for every time there's a change in configuration, it automatically delivers, or it automatically deploys the new configuration to the required shelves or to the required nodes. Then also we have improved operational efficiency. With improved operational efficiency, we have that's where monitoring and logging comes in, where we use tools like Prometheus, Grafana, ELK. There's one called the Cisco Thousand Eyes, which is actually a very interesting tool to use as well. Then also we have the Splunk. We have Splunk. I'm sure a bunch of us are quite familiar with Splunk too. So we use Splunk as well too. Then for improved operational efficiency, we have reduced manual intervention, where we don't where there's actually less human interaction in things like that. Also, we have the consistent and reliable deployment. For consistent and reliable deployment, that's where we talk about infrastructure as code, using tools like Ansible and Terraform. And for that, actually, using infrastructure as code, what we do in IAC is to define network configurations in codes instead of writing the traditional network configurations, where we have to log into the router and or log into the switch or log into the network devices and start writing thousands or hundreds of lines of commands. Easily, what we need to just do is just to get a certain template that can be reusable. We can always reuse the template, and I mean, for every time we need to carry out new integrations, all we just need to do is just to change some certain parameters within the template. Also, we're talking about rapid deployment and scalability. So for rapid deployment and scalability, we're looking to leverage on cloud-based solutions and virtualizations to scale network infrastructure either up or down based on demand. And now we're looking at tools like like Kubernetes or Docker to enable rapid deployment of network services and applications. Also, for rapid deployment, also it gives us the ability to be able to deploy. Okay, let me say faster time to market, because it reduces the time required to deploy new network services or features, enabling faster time to market for new initiatives, whereby we use that, and also for the faster time to market as well, it help us to use agile methodologies combined with DevOps practices to ensure that network time changes can be implemented quickly and efficiently. And also, rapid deployment and scalability, also, I could say, it allows us to have dynamic resource allocation, in the sense that we can use orchestration tools like Kubernetes to dynamically allocate network resources based on real-time demand. And more like it becomes flexible. It becomes, I mean, we include elasticity in it. So based on demand, it either scales up or it either scales out or it scales up based on demand. Then also it helps also ensure optimal performance and cost efficiency by automatically scaling resources as needed. Then looking at customization and innovation as well. Customization and innovation helps us to have tailored solutions because DevOps allows for customization of network configurations to meet specific business needs. It also helps us to be able to implement bespoke solutions that align with organization goals and objectives. Then also, it helps us to encourage innovation. It helps us to free up network engineering. It helps us to free up network engineers to focus on innovative projects and new technologies by automating routine tasks, and also to focus a culture of continuous improvement and experimentation, leading to better network solutions. And also, I think it also helps us to integrate with emerging technologies by maybe like seamlessly integrating new technologies and tools into the network environment. And also, it helps us to stay ahead of the curve by adopting cutting edge solutions and best practices in network engineering. So, just to quickly talk about the tools in network engineering, the tools for DevOps in network engineering. So, for the tools for DevOps in network engineering, for the configuration management, we use Ansible and Chef, which I'm sure a lot of us I'm sure a lot of us here today are quite familiar with all these tools within the DevOps space. And Ansible is one tool that almost everybody within DevOps space uses for configuration management. So we use Ansible in DevOps for network engineering because it's actually simple and is a simple and agentless automation tool, and it allows us to write. It uses YAML for configuration, and is actually ideal for network. Actually ideal for network automation. Because it's being a configuration management tool, it helps us to be able to configure multiple devices at the same time, and also gives us room to be able to prepare for disaster, to be able to set up disaster recovery as well. Chef on the other side Chef is more of a Ruby based solution for configuration, and Chef is actually excellent for managing complex environment. But I notice people don't really get to use Chef as much as possible compared to Ansible. Then for the CI/CD pipelines, I'm sure we are quite familiar with Jenkins and we are familiar with GitLab CI. Personally, I think I started my journey with using Jenkins, but these days I've been trying to play around with GitLab, using the GitLab runners and a bunch of other tools just to, play around the CI/CD. So for Jenkins actually is a open source automation server that is I could say it's actually one of the reasons why I like Jenkins is because it supports a wide range of plugins for various integrations. Jenkins is quite interesting. I think the only problem I have with Jenkins, I should say, is having to write Groovy scripts all the time. I think over time doing DevOps, I tend to prefer. I think the first time I tried using GitHub Actions and having to write YAML scripts, but every time I have to write a YAML script, I usually prefer having to write a YAML script over having to write Groovy, which we all know Groovy is that language for writing the Jenkins pipeline. I see a lot of people tell me, oh, they prefer to write Groovy rather than writing a YAML script. But yeah, personally, I like writing YAML scripts instead of writing Groovy. So I think the same for GitLab CI/CD as well. Is integrated with the GitLab is actually integrated with GitLab for seamless code and pipeline management. And I think for GitLab CI/CD, I think it's actually it has a strong support for Docker and Kubernetes, and it's actually ideal for CI/CD. So personally, I think I prefer GitLab CI over Jenkins. And the funny thing is that I think I met someone recently who said he has never who's actually a DevOps engineer that has been in the industry for about 4 or 5 years now, and he said he has never used Jenkins for once in his life, which is quite. I found it quite interesting and funny at the same time when we had a conversation. Yeah. So talking about network automation, so we have this Cisco NSO. Sorry, I like to speak about Cisco a lot because I'm actually a Cisco champion and at the same time an instructor of the Cisco Network Academy. So there's one time I'm trying to have a conversation where I always like to speak about Cisco because definitely I need to represent Cisco anywhere I am as an ambassador and as a champion, as a Cisco champion. So so talking about the Cisco NSO, which is Network Service Orchestrator, it's actually it supports multi-vendor environments, yeah, and it provides transactional safe network changes. Then also Python. I mean, we're all familiar with Python, which is a programming language. Python too also helps us. I mean, it's actually a very versatile programming language where we can use for so many things: data science, web development, automation. I mean, name it, anything you want to do, machine learning, AI, anything you want to do. We'll use Python for majority of all those things we want to do. So, and Python is actually very rich in so many libraries. It has a very rich set of libraries. And I mean, for people doing automation or network programmability, I know a lot of us use NetMiko. I mean, NetMiko is actually one of the major plugins sorry, major libraries we use in Python. Then it's actually very Python also I think is actually very one of the reasons why I like Python is because of it's been ideal for scripting and automating network tasks, basically. So now I'm going to monitoring. So for monitoring, I'm going to be talking about Prometheus and Grafana. So for me, Prometheus, yeah, Prometheus actually open source monitoring and alerting. It's actually it's an open source monitoring and alerting toolkit designed for reliability and scalability. I think, yeah, I mean, I used Prometheus a bunch of times and I really did find it interesting and I really did enjoy it a lot. Then also Grafana. Grafana is also open source. It's also an open source platform for monitoring and observability as well, which provides powerful and customizable dashboards. I mean, I think Grafana has very beautiful dashboards, definitely. And with these dashboards, you can see whatever is going on with your network nodes, your Cisco, your switches, your routers, your everything that is actually involved. And there's this other one too that I like to talk about, which is called the Cisco Thousand Eyes. The Thousand Eyes does so much more when we talk about network engineering. But definitely, I might still probably touch base with this thousand eye before the end of this before the end of my session. So so now let's talk about infrastructure as code. Infrastructure as code basically is the process of is actually the process of managing and provisioning computer infrastructure through machine readable definition files rather than physical hardware configuration or interactive tools. And why do we use IAC, infrastructure as code? It allows us for the automation and management of infrastructure in a consistent and repeatable manner, which is why I was talking about being able to reuse the other time when I was talking about Ansible. IAC allows us to be able to reuse the codes we had before. So there's nothing like wastage of codes or having to write codes all the time. You already have a template on ground, or you already have a playbook for your Ansible. All you just need to just to make modifications, make modifications based on demand, and push your scripts, and you get your configuration sorted out. I'm talking about the types of IAC tools we have Terraform, we have Ansible. So what are the benefits of IAC? Consistency. I mean, it ensures that the same configurations are applied across different environments. Just like I said the other time, we have less instead of when we do the traditional way gives us room for human errors. But using IAC, you already vetted your script. You're putting your script into production. The moment you vet your script and you put your script into production, there's not going to be an issue of human error. Then also reproducibility. It enables the recreation of infrastructure set up on demand, facilitating disaster recovery, testing, and scaling. The same scripts you have, you're reusing the scripts to reprovision other infrastructures. And I mean, no wasting of time. Easily disaster recovery. You're bringing everything back up without wasting so much time. Then scalability automates the scaling of infrastructure up and down based on corridor, just like I said the other time. Just like, I mean, you're trying to maybe what you're trying to do is maybe for 20 hosts. By the time you need more than 20 hosts, you need maybe like 50 hosts. You don't need to waste time. You don't need to delete anything. You don't need to bring anything down. work on your script, puts your script up automatically. It expands, it brings it down, expands, bring it down, expands, it bring it down. Okay, thank you. So talking about CI/CD pipeline in network engineering, So we're quite familiar with CI/CD pipelines, which is continuous integration and continuous delivery. For continuous integration, I mean, this is actually just like I explained there, the practice of automatically integrating code changes from multiple contributors in a shared repository several times a day. And what is continuous delivery? Continuous delivery is the practice of automatically preparing code changes for a release to production. CI is integrating your code changes from multiple contributors in a shared repository, just like shared repository like GitHub. Everybody's building. Continuous delivery is the practice of automatically preparing the code that has been built already, or whatever has been built already, ready for production. So now we're talking about integrating with the network configuration changes. We're still talking about CI/CD in network configuration changes. So just like I said, the network configuration as code. Treating network configuration as version controlled code allowing for automated management and deployment of network changes. Just like I said, your network configuration stays on your version control system. Changes are being made. When the changes are being made, automatically it goes through the CI/CD pipeline. When the change is made, everything it gets to the build, it gets to your several stages, and it's been sent into delivery or production following the CI/CD pipeline. And so we're talking about the integration points. We have the pre-commit testing, where in the pre-commit testing phase, automated tests on network configuration before they are committed to the repository. Tests are being carried out on your network configuration or on your network configuration as code. The codes that are meant to configure your network is being tested just to be sure that everything is fine, so it doesn't break anything. Then we have the continuous integration, ensuring that network configuration changes are tested and validated continuously. So it means before your code goes out, it's being tested and validated to be sure that everything is okay and everything is fine, so we don't break production. Then also deployment automation, automated deployment of validated network configuration to production environments. It means it deploys the validated configuration to production environments, which is the deployment automation. Everything has been checked, everything has been scanned and checked to be sure that everything is fine. It's not going to break anything. Then it's being deployed automatically. Your network configuration that's been validated is being deployed automatically to production. And we have the rollback mechanism. For those of us that have actually been familiar with being in the tech industry for a while, for every time you're carrying out a change, what we call a change maintenance, or what we call a change management, or for people that are familiar with the change management system, that for every change you're carrying out, you should always have a rollback plan. And the reason why we have the rollback plan is that should in case there's a problem that goes on while we're carrying out a certain maintenance or carrying out a certain change, we should be able to roll back to how it was before. So as to be able to focus on, okay, why did we have this error? What was the problem? What went wrong? How can we get this issue sorted out? And how can we carry out this maintenance again without having this problem? So everyone can go back to the drawing board and sort it out, which is why we have the rollback mechanism. So, but in this case, the rollback mechanism is being automated. So just like you said, the automated rollback procedures in case of configuration failure. So should there be any issue where your configuration fails, automatically there's a rollback, which means it rolls back just to be sure that your network doesn't break. Okay, so talking about CI/CD tools and the best practices. So I mentioned Jenkins. I spoke about Jenkins the other time. So Jenkins, like we all know, is an open source automation server for building CI/CD pipelines. All people, for those of us that actually been familiar with DevOps, doing DevOps, and people familiar with cloud engineering and all that, familiar with Jenkins. And okay, the feature of Jenkins, like I said, extensive plugin ecosystem. Jenkins has a very robust should I say database or ecosystem for several plugins, and it supports for pipeline as code. Jenkins supports for pipeline as code, and it has a very robust community for support. I mean, Jenkins I could say is one of the OGs when it comes to CI/CD. Then GitLab CI. GitLab CI is actually integrated, is an integrated CI/CD solution within GitLab for version control and pipeline automation. Also, the features seamless integration with GitLab repositories, powerful pipeline definition, and comprehensive monitoring. I think so far for me, GitLab is actually this is actually one CI tool that I think I find quite interesting lately, which I'm also still currently exploring to maybe to gain more skills or to actually get better. I really do find GitLab quite interesting. I think after I played a bit around GitHub Actions, I did find GitLab quite interesting. Then Ansible. Ansible is a automation tool for configuration management. Like I said, with Ansible, you can configure as much as possible devices or as much as possible nodes or shelves you want to configure with Ansible just by writing your YAML-based script. Just sit down, write your YAML-based script, blast your script, and you have several devices, several hosts across different geographical zone configured within a span of few minutes. Everything is up and running. Unlike having to start sending support staff to different location, having to carry console cables, connecting to router and switches, trying to bring them up. Then okay, so best practices, CI/CD tools and best practices. So for the best practices for CI/CD within the network engineering for DevOps for network engineering, which I also feel is I think just best standard practice so far within the DevOps space. We need to ensure that all code configuration and script are stored in the version control system. Your version control system, like could be GitHub, it could be, depends on any version control system you decide to use. Because I mean, this actually fosters collaboration between developers or between engineers or between the team. Then automate testing. Implement automated tests for both code and network configuration to catch errors early. So before you send your code out, you need to test to be sure that everything is fine. So you don't just send a code that is filled with bugs out into production and it ends up breaking your entire system. Then use staging environments. Always deploy to a staging environment before production to validate changes. So it's better to always move your code to staging environments. Look, I mean, being able to, when you move to staging environments, be able to be sure that everything is fine before your code goes out to production. Then monitor continuously. Implement continuous monitoring and logging to detect issues promptly and gather feedback. It's actually very important. Monitoring is actually very important for us. I mean, you need to see the health of whatever is going on to be sure that everything is fine and all that. Then implement rollback strategy, like I said the other time. I have automated rollback mechanism in place to quickly revert changes in case of issues. I mean, most of the time, people that are quite familiar with the network industry know that there's something called SLAs, service level agreements, and we have what we call the MTTR. MTTR is what could be mean time to repair, mean time to restore. Majority of the time, for people that are quite familiar with data centers and major network operators, you need to sign a certain SLA with your customers to tell them that, okay, I'm going to offer you maybe 99.99999% uptime. And this is my MTTR, this is my mean time to restore. It means if your link is going down, if your link goes down for any reason, it needs to be back up within the next 30 minutes. Which is part of why we integrate rollback strategy. Should there be a change being carried out? But usually before you carry out the change too, your customers need to be informed that, oh, hi, hi Safaricom or hi Orange or whatever it is, we're carrying out a certain change that's maybe 1 a.m. to maybe 2 a.m. By the time you get to 1:50 a.m. and your issue is still ongoing, you already have your everything automated. Okay, should this thing not work, automatically roll back and revert to what it was before to bring the customers back up. So that gives you time to go back and see where the problem was, why your schedule, why your activity, or why your maintenance wasn't able to work, or why whatever you were trying to work on wasn't able to work. So this is I added the use case real reward example of network configuration automation. I mean, DevNet for network engineering. So let's say a large enterprise with complex network infrastructure needed to streamline its network configuration management to reduce manual errors and increase deployment speed. I mean, they don't want errors during configuration, and they're trying to deploy faster. Let's say they have about 5,000 routers across several countries, or let's say they have, let me exaggerate, let's say they have about 1,000 routers across several countries. They have maybe about 5,000 switches, or I mean, they have several devices across several geographical zone, and they're trying to configure these devices within the next 1 hour. Will they have to send someone down to fly and start connecting locally to these devices? No. I mean, that's a waste of time. That's a waste of manpower and waste of so many other things. I mean, it's even going to cost them more. But now with automation, with network automation, with DevNet, I mean, we call it DevNet, I mean, or Net DevOps. Now, all the just need to just do is set up their devices with what's called configuration management tool. Boom, everything comes up within a certain number of minutes, and everything comes up. So this is just a real life scenario of how network configuration automation or how DevNet works. It helps us to be able to configure several nodes, several agents, or several devices within the shortest period possible. So talking about monitoring and logging, I spoke about monitoring and logging the other time. It's actually a very important part of net DevOps, or part of DevOps in network engineering as well. The importance of of monitoring and logging is continuous insight. For continuous insight, we need to always see what's going on. Continuous insight, we need to always see what is going on. Monitoring real time to see what the issue is. Should we be having any issues? Performance, network performance, health of network infrastructures. It also helps us to be able to identify issues before they impact users. Then operational efficiency. For operational efficiency, we get automated alerts, and dashboard helps. I mean, it helps network engineers to be able to quickly diagnose and resolve problems. I mean, tools like Nagios, for people that are quite familiar with Nagios. Then data-driven decisions. The monitoring data helps in understanding network trends. I mean, you're seeing maybe it goes off, it goes down. Customer need more. The customer base is growing. They need more capacity. They need more bandwidth. They need. I mean, so many things going on. So this actually helps us to be able to see what's going on, and also facilitates data-driven decision making for network optimization and upgrades. Then compliance and security. I'm actually very big on security and very big on compliance as well. So continuous monitoring actually ensures compliance with security policies and regulatory requirements. It also detects anomalies and potential breaches promptly. So this is part why we actually require, I mean, these are reasons why we require monitoring and logging. So now let's look at the tools we use for monitoring and logging. We have Prometheus, which I spoke about the other time. Prometheus is open source and open source monitoring and alerting toolkit, and features collects metrics from network devices and applications. Also, it stores time series data, which can be queried using PromQL. Then we have Grafana. I'm sure people doing DevOps are quite familiar with Prometheus and Grafana. Grafana also is open source for monitoring and observability. Feature, it actually visualizes metrics collected by Prometheus in interactive dashboard. And it's also customizable. It has a customizable dashboard to track specific network performance indicators. Then we have the Cisco 1000 highs, which I like to talk about a lot. I mean, I've seen Cisco 1000 highs in I've actually been opportune to see Cisco 1000 highs in, I mean, seeing how it performs and how it works and how it picks up trends, how it picks up issues, and it localizes issues to the nearest available zone where the error has occurred. And I mean, it's actually a very fantastic and beautiful solution. So Cisco Thousand is actually network intelligence platform for monitoring and visibility. It provides detailed insights into network performance from an end user perspective. It monitors network path, just like I said. It monitors the network path from your point from point A to the point Z. So it means from the end user to wherever the link is being terminated on the internet or wherever the link is going to. It monitors from the beginning to the end of the circuit. Then it also gives real-time and historical data analysis for troubleshooting and optimization. So Thousand Eye also shows you where the problem is. It shows you that, okay, this is where the issue could be. This is what the problem is. This is the last whoever noticed and all that. And it gives you that opportunity to be able to quickly diagnose and repair any network issue you're having. Then we have Splunk. I mean, I think for people that are actually within the SOC industry, the Security Operations Center analyst, I'm sure a lot of them are actually familiar with Splunk. So Splunk is actually role data analytics and monitoring platform. Splunk collects and indexes and analyzes matching data in real time. It provides powerful search, analysis, and visualization capabilities. And it also enables proactive troubleshooting with customizable data and alerts. So I think this is where I'm going to end my presentation on the DevOps in network engineering. And for more insights, you could actually visit this website, and I could also be reached on Twitter if you'd like to have more discussions about net DevOps. Thank you very much, guys. And also, I'm actually very sorry for not being able to be live in Nairobi in person. This was actually due to unforeseen circumstances, and hopefully by next year, I'll be able to join you live in person. Thank you very much.